Welcome to CSC324, and today what we're going to talk about is a different way of thinking about building a Python-based application. So the experience that you've just gone through or you're finishing up for your first email application was probably pretty intense. There was a lot of code that you had to write in Python, so you were learning a new language. That was a big struggle, but I'm guessing that it was also probably a bit of a struggle just to figure out how to organize all of the different moving parts of the application that you wrote. And so what I want to do is talk about some really good software engineering principles that will help you organize your code. And so what we're going to do is we're going to look at the book voter application again and use that as a model to explore these principles. And then you are going to go back to your email application and rewrite it using these principles and resubmit the application. This is kind of cool because it's not very often that you actually get the chance to rewrite any code that you've written. It's kind of like, I don't know, if you, I think there's a truth in if you build something the first time, by the time you're done building that thing, you actually know how to build that thing correctly. Does that make sense? Like, you built it wrong, but it sort of works. But now that you know everything you know about that first build of the system, you now know how to build the system correctly. So you get to do that with the book, with the email application that that you wrote. Okay, so let's take a look at the book voter application. First, I just want to run through it again to remind you how it works. And then what I want to do is talk about some really great software engineering design principles that will make writing or rewriting book voter a little easier. So we have a login screen, and I'm going to put in my user ID and my password, CSRocks55. Don't tell anyone. And now I'm going to vote for a book. So given the stuff that's going on with coronavirus, I'm going to vote for The Stand. If you haven't read it or you don't know about it, you should check it out. Okay, we'll just wait for that to wrap up. One of the things points I want to make about just running through this is this version of the book voter application, it's exactly the same as the book voter application that we looked at the last time we were together. So really, there's no difference in the user interface. And so if you think about the email application that you're writing, version 2 of the email application, the one that uses the design principles we're about to talk about, it should look pretty much the same as version 1. It should look the same, but the code behind it will be different. Okay, so let's put that aside and let's talk about some design principles. So the first really important design principle is something called, I guess we just do this, something called the ModelViewController design principle. So I'm going to write this down. So all right, so CSC324. And what we're going to look at is a homegrown web framework. What we just built prior to break was a homegrown web application. But what we're going to do now is build our own web framework. This often happens in development shops. If you are building a system, you'll notice that there's certain strategies that you use as you build out parts of the system, and you keep using those strategies over and over again, and then it kind of makes sense to follow a set of principles in order to build out new parts of the system. Okay, so one part of the homegrown web framework that I want to talk about is something called ModelViewController. So the model view controller, or people say it more quickly, MVC, is an example of something that is called a design pattern. Now, design patterns are ways of writing code that seem to be particularly effective at solving common problems. So when you're building any kind of application that has a user interface component to it, it is very, and also some kind of data store. And it is very common that you will find the model view controller design pattern to be super useful, because there's something called a view, that's usually your user interface. There's something called a model, that's usually your data store. And then there's something called a controller, which is the thing that interfaces between the view, your user interface, and the data store model. So we've got three different pieces. So what I want to do now is draw a couple pictures, talk about this in the abstract, and then what we're going to do is we're going to look at the code in Python that makes the model view controller framework work. And when you look at it, you're going to be like, oh my God, this application is so clean, it's so organized, it's so tidy, and I'm hoping that it's going to influence you and make you want to go into your own email application and clean it all up using the model view controller design pattern. So are you ready? All right, let's go. So first what I want to do is just kind of sketch out the idea. All right, so the basic idea is that the view of a model should be independent of the model. So I'll just say that again. The view of a model should be independent of the model. What does that mean? It means that the model doesn't know anything about the view. And so what does that mean? Well, all right, let me show you. So imagine that we had a list of, let me think. So imagine that we had a list of the number of A's, the number of B's, the number of C's, and so on forth for grades in a class, okay? So I'm going to say that this is the model down here. Here's my model. Okay, so in my model, I'm actually going to move that to the awesome power. Can't do that on a whiteboard. Okay, so in my model, I have four A's, 3 B's, 4 C's, 1 D, and 0 F's. Okay, so that's my model. So the model is basically a list. Maybe it's, maybe you can think of it as a dictionary or something like that. And it's a count of the number of A's, B's, C's, D's, and F's in a course. Okay, so that is data that's residing in your application. Now, what we'd like to be able to do is we'd like to be able to let the user see that data. So one way we could do that, and I'm going to call this view number 1, one way we could do that is we could print out to the screen basically a dump of the model. So like if the model was representing a file with these records in it, we could just print them out. So view number 1 would be maybe I would say like A, 4, B, 3, C, 4, D, 1, and F, 0. So this gets printed out to the screen. It's just text. All right. And that's pretty much all you can do with that view. You just look at it. All right. But there's other ways that we could view this. So you can imagine that view might be, I don't know, it might be a program that you're running on a personal computer. And somehow that program connects to the model and says, hey, model, get me all your information. And then it just dumps all of the information to the screen. Another way that we could view this model might be something like a pie chart. Okay, so this is view number 2. All right, so we have a pie chart. So, well, what does that look like? Well, we could have this little pie chart here. And then we're going to have, I don't know, I'm not going to do this completely perfectly, but let's say that's the number of A's. This is the number of B's, not quite as many. This is the number of C's. And it doesn't quite work out here. So let me make the number of A's just a little bit bigger. The A's and C's are a little bit bigger. The number of A's, the number of C's, and then the number of D's here. So that's a pie chart. So that's another view of the same model. It's the same data. We have another view of the same data. And then let's look at view number 3. So maybe this pie chart is something that's showing up on your mobile phone, your mobile device, all right? You're like, let's check out the grade distribution for the course, and you're running some app, and the app somehow connects to the model and queries it. The model has this information right here, and it pulls the information out and displays it as a pie chart. Now let's look at view 3, view number 3. Okay, so view number 3, maybe view number 3 is a bar chart. So we have A, B, C, D, and F. And the bar chart shows this is the number of A's, this is the number of B's, this is the number of C's, and this is the number, oops, let's go back on the D there. This is the number of D's, and there's no F's. So view number 3 shows that. Okay, but it's the same model. Each one of these is viewing the same data, but viewing it in different ways. Now, maybe that's on a website. So you're on the websites and you're looking at the grade distribution through a web browser. Now, what if we make this even more interesting? What if you could grab the number of B's with your pointer, so you could grab right there, and drag it up so that in the process of doing that, the number of B's goes up by 1, and now we have 4 B's. So we're dragging this bar up and incrementing the number of B's. That action in the view means that the user wants to change the number of B's. Well, by that action, the number of B's will change from 3 to 4. And in the process of doing that, what's going to happen to this pie chart is that the pie chart will automatically get updated. And just move some stuff around here to make this all work. now the number of B's and the number of A's and the number of C's are all equal. And over here, this view will change so that the number of B's is 4. So by this view action, pulling the column up by 1 in the web browser, it changed the model here and incremented B, and that updated the view of the pie chart and the view on the screen of the grades for B. Pretty wild, huh? All right, well, let's talk a little bit about conceptually, how does that magic happen? I mean, how is it possible here on view 3 to pull this bar up? Well, depending on where this is being displayed, so if we're talking about a web browser, you're talking about code that's probably JavaScript code that's sensing where the cursor is, and it senses that the cursor is clicking on that bar. And there's some Java code that says if the user tries to drag the bar up, move it up, and then let the model know that, well, actually a better way to say it is move the bar up, and then let the back end, the software that's managing the model, know that the bar moved up, okay? And the back end then says, oh, the bar moved up, so that means, and it was the B bar moved up, that means I should increment B by 1. And so it changes the model B to 1. And, oh, by the way, maybe I should let all the other views know about this change, okay? So that back-end component is something called a controller. So the controller acts as glue between views, between a view and the model, and it updates and modifies and manages the model. So if we go back here, if we've got, let me get some color in here now. So we've got a change to bar B, then that change is then sent to the controller. The controller then says, oh, the bar got changed. That means add 1 to the model. So the model gets changed. And then the controllers for view 2 and view 1 get notified of the change, and they update their views. So I'm going to write over here, we've got a view 2 controller, and a view 1 controller. All right, so the view 2 controller basically provides the glue that lets the model talk to view 2 and view 2 talk to the model. And the view 1 controller lets the model talk to view 1 and view 1 talk to the model. You can imagine, for example, over here with view 1, maybe the user could click on C, the row C, and hit the plus or minus key, which could change the value of C on the screen. And in the process, that change would then go back to view number 1's controller, view number 1 controller, which would say, oh, the plus key was hit. That means we need to change the row C and increment it by 1, and then it would go to the model and say, hey, row C, add 1 to yourself, and so row C would say, okay, now I have a count of 5, and then row C would say, okay, I've changed, and then all the views would be informed of the change, and then via their controllers. Well, sorry, the model would change. They inform the controller that it changed, and then all of the controllers would then update the views appropriately. All right, so that is the big idea of this thing called the Model View Controller Architecture, or MVC. Model View Control Design Pattern, or MVC. So what does that have to do with the work that you've done with the email program? And more specifically, since we're going to use BookFloater as sort of our exemplar application, what does it mean for BookFloater? Well, we can go back to BookFloater and rewrite it using the Model View Controller architecture. And if we do that, what it's going to do is create an amazing, really amazingly clean set of code to work with. Because when you're working with a piece of code, what you're going to be doing is answering this question. Does the code I'm writing at this moment belong in the model? Does it belong in the view? Or does it belong in the controller? It's going to be one of those places. And it isn't going to be anywhere else. So that's kind of cool. And so what you end up doing is you end up creating basically 3 different pieces of code. One code for the model, one code for the view, and one code for the controller. Okay. I'm going to stop there.